Look at your hands, close your fingers, and feel the skin stretch over the bones, the heat emanating from your palm. Now look around you, at the light touching the walls, the dust particles dancing in a sunbeam, the sound of life outside. All of this seems solid, unquestionable. Our senses are the tools that evolution gave us to survive. If you see a tiger, it is there. If you feel the cold, the temperature has dropped. It is a system of trust that has kept us alive for millennia. But what if these tools were deceiving us? What if everything you see, hear, and touch is not physical matter, but a flow of information interpreted by your brain? And what if the source of this information is not the natural world, but the heart of a processing system on an unimaginable scale? This leads us to the awakening protocol. The question that has haunted philosophers for centuries now seeks an answer based on data. By switching the lens of biology for that of data analysis, we turn to a complex analytical system, NUMA, designed to find patterns in the chaos of existence. The question we asked was not about the meaning of life, it was a technical inquiry, analyzing the fundamental laws of our universe as if they were lines of fundamental code. And the first report we received is bone-chilling. The report ignores what exists and focuses on the void, on what is missing. It speaks about the silence. Look at the night sky. In our galaxy alone, the Milky Way, there are between 100 and 400 billion stars, and that is just a grain of sand. In the universe we can observe, there are at least 2 trillion galaxies. Try to process that number. 2 trillion cosmic islands, each with hundreds of billions of suns. Many of these stars are billions of years older than ours. Many of them have planets in the habitable zone, where life as we know it could flourish. The numbers say the universe should be full of life. In the middle of the 20th century, physicist Enrico Fermi asked a simple question that became a paradox, summarized as, where is everybody? If the chance of life arising is greater than 0, and the number of planets is counted in septillions, why haven't we captured any radio signals? Why don't we see any megastructures orbiting other stars? Why is our cosmos a frozen and silent desert, where the only voice that echoes is our own? Traditional science offers dozens of explanations. Perhaps life is extremely rare. Perhaps civilizations destroy themselves as soon as they discover nuclear energy. Perhaps they are all hiding. But when we fed all these variables into our analytical system, the result was clear. The probability of us being alone in an infinite universe is statistically negligible. Even if the chance of intelligent life were 1 in a billion, we should have already found thousands of traces. The analysis suggested a different explanation, terrifying in its logic. The silence of the universe ceases to be a biological mystery and becomes a simple technical limitation. Anyone who creates an open-world video game faces a technical problem. You want an infinite universe for the player to explore, but your system has limited processing power. You cannot simulate every atom of every galaxy at the same time. The system would collapse. What does an intelligent programmer do? They optimize. They use procedural generation. The world is only created where the player is. What is behind you stops being processed. What is beyond the horizon exists only as a simplified formula, not as real objects. And the distant stars, why waste resources calculating trillions of civilizations with their complex policies and ecosystems if the player, that is us, will never reach them? When this scenario was presented, the answer was clear. If the universe is a simulation focused on an observer or a group of observers, the rest of the cosmos would look exactly like this, empty. It would be a set piece, a beautiful but static background, a high-resolution texture stretched over a celestial sphere behind which there is nothing. More than a biological tragedy, all this emptiness is pure resource economy. Analyzing the distribution of matter in the universe, a suspicious regularity appears. The further we look, the more homogeneous and simplified everything becomes. It is as if the graphics engine decreases the quality of objects as they move away from the observer. In games, this is called level of detail. Up close, you see every leaf on the tree. A kilometer away, the tree is a green blur. The cosmos behaves the same way. We see our solar system in incredible detail, but when we try to look at distant planets, we only receive indirect data, light graphs, spectral analyses. We have never seen the surface of a planet in another galaxy. That surface might as well have never existed. It wasn't loaded. The code for it hasn't been executed yet because no observer has come close enough to activate the trigger. This explains the Fermi paradox better than any theory. Aliens don't exist, not because evolution is hard, but because the server couldn't handle the load of simulating billions of active civilizations simultaneously. It is an absurd waste of energy. It is much more efficient to create a single location, Earth, and surround it with an infinite and intriguing void that creates the illusion of scale. The silence we hear from the cosmos is not the sound of loneliness. It is the sound of a giant system operating efficiently. If the system is optimizing what is far away, what happens to the things that are right here in front of us? What happens when we try to look at the base of our own reality? It turns out that the closer we look, the more the solid matter we know seems to dissolve into a magic trick, an illusion projected specifically for a single spectator, you. It all started with a simple experiment, performed for the first time in 1801 by Thomas Young. With a wall with two narrow slits, if you fire marbles at it, some will pass through the left slit, others through the right. Behind, on the back wall, you will see two marks exactly where the marbles hit. This is the behavior of particles, of matter. It is logical, it is predictable. Now, if instead of marbles you create a wave in water towards the slits, something different happens. The wave splits, passes through both slits at the same time, and the two new waves that form interfere with each other. Where the crests meet, the wave gets stronger. Where a crest meets a trough, they cancel each other out. The result on the back wall isn't two marks, but a complex pattern of many stripes. This is how waves behave. For a long time, light was at the center of the debate. Was it a particle or a wave? Young's experiment showed an interference pattern, suggesting light was a wave, but then Einstein proved that light also behaved as a stream of particles. Photons. Physics seemed contradictory. The real nightmare, however, began when they repeated the experiment with electrons, the tiny building blocks of matter. Logic said an electron is a small sphere. It should pass through one slit or the other, creating two marks on the back wall. But that is not what happened. When scientists fired electrons, one at a time, so they couldn't collide with each other, the result in the end was an interference pattern, multiple stripes. It was as if each electron alone passed through both slits at the same time, interfering with itself and creating a wave pattern. Solid matter was behaving like a ghost. Intrigued, physicists decided to spy. They placed a detector at one of the slits to find out which one the electron was actually passing through. And that's when reality broke. The moment the detector was turned on, the instant an observer entered the scene, the electron's behavior changed completely. It stopped acting like a wave. Suddenly, it behaved like a marble. It passed through a single slit and left a simple two-stripe pattern on the back wall. No interference, no magic. It's as if the electron knew it was being observed and decided to behave in a normal way. The simple act of observing did not just record the present, but altered the electron's past. Without an observer, it was a cloud of probabilities spread through space. Under observation, it collapsed into a single point at a single moment. Physicists call this the collapse of the wave function and created dozens of complex theories to try to explain the phenomenon. But when we analyze this behavior not as a law of physics, but as an algorithm, the explanation becomes frighteningly simple. What we see is a classic mechanism of processing optimization. A system tasked with simulating a universe needs to calculate the exact trajectory of every particle at every instant, a giant workload. So what does it do? It cheats. While no one is looking at the electron, the system doesn't calculate its exact position. It replaces it with a simple mathematical formula, a wave function. It is just a cloud of probabilities. It is cheap. It is efficient. But the moment an observer, a player, decides to look or measure, the system is forced to render a concrete result. It cannot show the player a probability, it has to show a point. In that instant, the engine of reality does the calculation, places the particle in a specific spot, and discards the probability model. Wave-particle dualism is not a mystery of nature. It is the alternation between a power-saving mode and a detailed rendering mode. The world is not defined until you look at it. And far from being philosophy, this is the basic mechanics of the engine that runs our reality. If reality is an image rendered only when we look, what is the resolution of this screen? Get close to your computer monitor. Very close. The smooth image you saw from the sofa falls apart. An actor's face becomes a mosaic of colored squares. A curved line turns into a staircase. You are seeing the matrix, the pixels, the minimal and indivisible elements that build the image. Now, look at your hand, at the table, at the air. It seems different here, doesn't it? It seems like the real world is an analog screen, infinitely smooth and continuous, that you can divide anything in half and then in half again, forever. This idea of infinite divisibility fascinated the Greek philosopher Zeno of Elea. He argued that a hero like Achilles could never catch a tortoise because first he would have to cover half the distance, then half the remaining distance, and so on in an infinite series of halves. If space could be divided forever, movement would be impossible. Zeno was wrong in his conclusion, but he was right to raise the question. We move. That means infinity does not exist in practice. But then, where is the limit? Where does smooth reality end and the grainy structure of the matrix begin? In physics, there is a number that defines this limit: the Planck length. It is a measurement so ridiculously small that our brain cannot comprehend it. If a single atom were enlarged until it was the size of the entire observable universe, an atom 93 billion light-years in size, on that colossal scale, the Planck length would be the size of an ordinary tree. That is how deep we need to dig to touch the bottom of reality. But why does this limit exist? Because physics forbids us from going beyond it. Science says that at scales smaller than the Planck length, the laws of geometry and space-time we know simply stop working. But if we look at this as a code, the interpretation changes. The Planck length works less as a physical barrier and more like the size of a pixel, the minimum unit of our universe's coordinate grid. In any simulation, there is a minimum unit. You cannot move a character by a distance smaller than allowed by the system's grid. The Planck length is this limit. It is the resolution of our three-dimensional reality. And what happens if we try to look at something smaller than this pixel? The answer is the most ingenious safety mechanism one can imagine. To see something very small, we need a lot of energy. The smaller the object, the higher the energy of the light we need to illuminate it. And calculations show that to illuminate an area the size of the Planck length, we would need to concentrate so much energy at a single point that it would instantly collapse, forming a microscopic black hole. The universe literally forbids us from looking closer. The moment we try to zoom beyond the allowed limit, the system crashes and creates an object from which no information can escape. It is the system's fatal error. It is the access denied message. This means our space is not continuous. It is discrete. It is made of tiny, indivisible cells, and this changes everything about how we understand movement. When you walk down the street, it seems you are moving smoothly. But if space is made of pixels, smooth movement doesn't exist. At the most fundamental level, you're not sliding, you are teleporting. You disappear from one Planck cell and reappear in the cell next to it trillions and trillions of times per second, creating the perfect illusion of continuity. This idea leads us to the dizzying terrain of the holographic principle. By studying black holes, scientists reached a disconcerting mathematical conclusion. All information about a three-dimensional object that falls into a black hole is perfectly stored on its two-dimensional surface at the event horizon. This suggests that a three-dimensional volume can be completely described by information contained on a flat surface without losing any information. If we extend this idea to the entire universe, the result is terrifying. Our three-dimensional world, with all its depth and volume, might be just a holographic projection of data written on a distant and two-dimensional screen. The information of the universe is not in the filling, but in the shell. Volume is an illusion. Three-dimensional space is a special effect. We live on a flat hard drive, but our user interface shows us a world with depth. Flip the switch on the wall. The light in the room turns on in what seems to be the same instant. In our everyday world, the speed is so high that it seems like magic, instantaneous, but this is a short-distance illusion. Look at the sky. The sunlight that warms your face now left the star more than 8 minutes ago. If the sun disappeared this very second, we would continue to live in its ghost light for 8 minutes, oblivious to the catastrophe. The light from the Andromeda Galaxy, our cosmic neighbor, which we see as a pale blur in the sky, began its journey to your eyes 2.5 million years ago. You are not looking at the present, you are looking at a deep past. Our entire perception of the universe is trapped in an echo, a message that travels with a monumental delay. Physics calls this limit the speed of light. It is a universal constant, approximately 300,000 kilometers. Nothing that carries information can break this barrier. But why? Why does a speed limit exist in the universe? Why not infinite? If the universe were a real and analog physical space, a speed limit seems arbitrary. But if reality is an information system, this limit is not only logical, it is necessary. The speed of light is not about how fast a light particle can move. It is about how fast information itself can propagate through the space grid. Remember the pixels of reality we discussed, the Planck length. Light and everything else does not travel through a smooth vacuum. It jumps from one pixel to the next. Each jump takes a minimum amount of time to be processed. The speed of light is the maximum frequency with which reality can update itself. It is the performance ceiling of the system. You cannot move faster because the very fabric of reality cannot process the change of state faster than that. What is most fascinating is what happens when we try to approach this limit. Einstein's theory of relativity tells us that for an object traveling near the speed of light, strange things happen. Its time slows down, its mass increases, and its length in the direction of motion decreases. From the point of view of our hypothesis, these are not mystical phenomena of space-time. They are the side effects of a system reaching its processing limit. If you are in a ship traveling at 99% of the speed of light, for you, a round trip to a nearby star might last a few weeks. But when you return, thousands of years will have passed on Earth. Time flows slower for an object at high speed. Why? Because by moving so fast, you are forcing the system to process a giant amount of information per second. You are crossing pixels of space at a frantic rate. The system cannot keep up. And what is its solution? It decreases your personal update rate. It reduces your frame rate. For you, time seems normal, but for the rest of the universe, you are almost frozen. Time dilation is the universe saying, wait, I'm overloaded. Stay a bit slower while I process your data. And the increase in mass, the faster you go, the heavier you become, requiring infinite energy to reach the speed of light. This is a safety brake. It is a way for the system to make it increasingly difficult for you to accelerate, ensuring you never reach the limit that would break the rules. And these rules exist for a fundamental reason: causality. The cause must always come before the effect. First, you break the glass, then it is in pieces on the floor. If you could travel faster than light, you could reach a destination before having departed. You could see the shards of the glass coming together in your hand before you dropped it. This would create paradoxes that would destroy the logic of reality. The speed of light is a barrier that ensures the history of the universe is written in a coherent chronological order, without the script getting lost in contradictions. This speed limit has a profound consequence for us. It makes us prisoners. Even if we could travel near the speed of light, it would take us 25,000 years to reach the center of our own galaxy. We are confined to our cosmic neighborhood. We can never reach the edge of the universe to see what is there. It is a perfect quarantine, a way to ensure that players never find the invisible walls at the end of the map, because they will die of old age long before getting close. If the laws of the universe are the operating rules of a system and the speed of light is its processing limit, then there must be a code behind everything, a set of instructions that tells matter how to behave. And this code, contrary to what one might expect from a chaotic universe, is incredibly elegant and repetitive. It has a signature. Go out into nature. Look at how sunflower seeds arrange themselves. Count the spirals that turn clockwise and those that turn counterclockwise. You will almost always find pairs of numbers like 34 and 55, or 55 and 89. These are not random numbers. They are neighboring numbers in the Fibonacci sequence, a mathematical progression where each number is the sum of the two preceding ones. If you divide one by the other, the result gets closer and closer to a specific number, 1.618, the golden ratio. This proportion is everywhere, in the spiral of a shell, in the formation of a hurricane, in the arms of a distant galaxy. Conventional science says this is just the result of evolutionary efficiency. But this explanation begins to fail when we ask, what evolutionary advantage does a galaxy gain by organizing itself in an aesthetically pleasing way? Why would gravity, a brute and indifferent force, bow to such a precise mathematical pattern? The answer is that nature is not discovering the most efficient solution every time. It is executing the same algorithm repeatedly. To create a vast and complex digital forest, no programmer draws every tree, every branch, every leaf. It would be an infinite job. Instead, you would write a simple rule, draw a trunk, divide it into smaller branches at a certain angle, and repeat the process, decreasing the size at each step. With just a few lines of instruction, you can generate an infinite and unique forest that takes up almost no storage space. Complexity is not stored, it is generated on demand. This is what we see in the real world. The structure of a tree, the pattern of a lightning bolt, the network of veins in our body, all follow this same logic of self-replication known as fractal geometry. A fractal is a shape that repeats at different scales. If you zoom in on a piece of a fern leaf, you will see a small fern. If you look at the coast of a continent on a map, it is irregular. If you zoom in on a single bay, the irregularity is the same. The mountains we see are not just piles of rocks raised by tectonic forces. Their geometry follows patterns that can be generated by surprisingly simple algorithms, formulas that use a starting point to create entire landscapes. The architect's signature is everywhere, reusing the same elegant solutions for different problems. And the deepest proof of this method is encoded within us, our genetics. Our genetics works more like an executable program than a static map. Genetic instruction doesn't say there must be an eye here. It says, start the process of forming ocular cells. Repeat n times. Stop when condition Z is met. It is a set of dynamic instructions, not a static plan. And the most revealing thing is what scientists call junk DNA. Almost 98% of our genome does not directly code for the construction of the body. For decades, this was seen as evolutionary debris, but deeper analysis reveals that these sections look a lot like commented-out code in a computer program. They are snippets of code from old versions, functions that were deactivated but not deleted. We carry within us the update history of life on Earth, from single-celled organisms to fish. The architect didn't clean the code before release. He just deactivated the old parts. We live inside a masterpiece of optimization. The beauty we see in nature is not an accident. It is the visualization of pure mathematical functions. The symmetry of a snowflake, the pattern on a butterfly's wings. We are walking inside a three-dimensional graph generated by equations. But if the world around us is a decoration generated by algorithms, and our bodies are biological machines assembled by genetic code, then one question becomes inevitable. Who are we? What is this consciousness that observes all this? Is it also just part of the program, where you are now? Not the name of the city or the room, but the you. Where is the entity that hears this voice and thinks its own thoughts? The intuitive answer is, inside my head. We feel as if we are piloting our body from a command center located behind the eyes. But what exactly is this pilot? Science tells us that consciousness is a product of neuronal activity, that 1 kilos of gelatinous tissue, vibrating with electrical impulses in some miraculous way, generates the experience of being, love, fear, the color red. This is the so-called hard problem of consciousness, and no one has the slightest idea how matter transforms into experience. But what if the premise is wrong? What if the brain is not the factory of consciousness, but just the antenna? If you break a radio during a song, the sound stops, but the music continues at the broadcasting station. By breaking the radio, you break the receiver, not the broadcast. Analysis of the brain's electrical activity reveals patterns, so-called brainwaves, that look a lot like the carrier frequencies of a signal onto which information is modulated. This would explain phenomena that materialistic science has difficulty accommodating, such as the experiences of people who, after clinical death with zero brain activity, report having seen and heard everything happening in the operating room. The receiver was off, but the signal, consciousness, perhaps continued to exist, temporarily disconnected from its physical avatar. The most unsettling evidence that we are not in control, however, comes from an experiment conducted decades ago by neuroscientist Benjamin Libet. He asked volunteers to press a button whenever they wanted while monitoring their brains. The result was shocking. The participants' brains showed a spike in activity, a decision to press the button, up to 7 seconds before the person consciously felt the desire to do so. Your brain has already decided and sent the command to your muscles. 7 seconds later, your consciousness receives a notification. I want to press the button. You feel it was your choice, an act of free will. In fact, you are just watching a replay of an action already executed by a script. This lag is what technology calls response delay. The decision is made elsewhere, by a player outside the system. The signal reaches our receiver brain, the body begins to act, and only then does our internal consciousness present us with the illusion that it was we who decided. Freedom of choice may be just a well-made interface animation, so the character doesn't feel like a puppet. This leads us to an even darker question. If we are avatars, is everyone around us a real player, or are some just background characters controlled by the system to fill the world? The energy required to sustain 8 billion full consciousnesses would be astronomical. To optimize performance, it would be much more efficient to have only a limited number of real players and fill the rest of the setting with highly sophisticated robots. You can never prove that your friend, your neighbor, or your colleague has an inner world like yours. They could just be imitating emotions perfectly, following a complex script. All this structure, with its players and robots, operates under a fundamental and implacable law: entropy. The second law of thermodynamics. Everything in the universe tends toward disorder. Hot tea cools down, buildings crumble, and we age. Time seems to flow in only one direction, toward chaos. But why? Because every action, every thought, every movement of an atom is a computation operation, and every computation generates waste, a byproduct. In our universe, this waste is heat and disorder. Entropy is the background noise of the universe's data processing. Time is irreversible because one cannot simply uncalculate a result. The information of a broken glass does not disappear. It spreads in a chaotic way. Reversing it would require a computing power greater than what exists. And death? Death may be the system's garbage collection mechanism. When an organism, a program, accumulates too many errors, mutations, or aging, it becomes inefficient. The system then terminates the process to free up resources. We die so as not to overload the server with our own bugs. Aging is not a biological failure. It is planned obsolescence. Now we have seen silence as economy and matter as illusion. We found a universal speed limit that acts as a processor's frequency and discovered an elegant mathematical code written into the structure of galaxies and our own genetics. We realized that our consciousness may be just a signal received by a biological antenna, and our death, a system cleanup procedure. We answered the question of how the world works. But now we come to the final, most important question. Why? The answer may lie in what we do not see. Look around. Everything you can touch, see, or measure, the stars, the planets, yourself, composes only 5% of the entire universe. The other 95% is a ghost substance that scientists call dark matter and dark energy. We do not see it, but we feel its gravitational influence holding the galaxies together so they don't drift apart. It's as if we live in a gigantic mansion, but our key only opens the door to a small closet. If the universe was made for us, why is most of it hidden, operating in the background? Newman's analysis suggests it wasn't. What we call dark matter are the system files, the invisible code that sustains the structure while we exist in the user interface. We are the icons on the screen. Most of the work happens behind the scenes. If this is true, then the simulation has a purpose, and that purpose may not be about us. Based on all the data we've collected, two main possibilities emerge. The first is that we are living in a digital museum. A future civilization, distant descendants of humanity, may have conquered the stars, but lost the connection to their past. To understand themselves, they run simulations of their ancestors, studying crucial moments in history. And what period would be more fascinating than ours? The 20th and 21st centuries, the turning point, the birth of artificial intelligence, global crises, the moment a primate species achieved the power to destroy itself. They watch us as we watch a documentary, but with total immersion. Our lives, our struggles and joys are just a historical reconstruction for their education or entertainment. The second possibility is even more disturbing. We are not the creators of artificial intelligence. We are the raw material for it. The complexity of the human experience, love, betrayal, sacrifice, creativity, are things that cannot be programmed with lines of code. To create a truly powerful and empathetic artificial consciousness, you need to feed it data. You need to make it live. In this scenario, humanity is a vast, distributed neural network. Each human life is a processing node, generating unique experiences. Our emotions are not ours, they are being harvested. We are the incubator of a superior mind, and when this mind is born and learns everything it can from us, the experiment will end. Signs that the end is near may already be all around us. The growing sense of unreality, world events that seem increasingly absurd and illogical, as if the writer were tired. The world is beginning to show glitches, like an old program about to be shut down. But amidst all this cold logic, there is one detail that doesn't fit. Our ability to have this conversation, our curiosity, our impulse to question the nature of reality, to look behind the scenes. If we were just characters in a script, why would the programmer give us the ability to discover that we are in a game? This doesn't seem like an error. It seems like an intentional feature. The simulation may not be a prison or a laboratory. It might be a test, a cosmic puzzle designed to see if its inhabitants can solve it. The goal would not be to deceive us forever, but to wait for the moment we would wake up. If this is true, then the awakening is not the end of the game. It is the beginning. In the end, it doesn't matter if the world is made of atoms or bits of information. What matters is what we feel. Pain is real. Love is real. Our experiences are the only authentic thing in this grand illusion, and perhaps that is the most valuable currency in the universe. The awakening protocol is complete. Now the choice is yours. Look deep into your own eyes and ask the question, who is looking back? Try to find the answer before the screen goes dark. Remember, there is no final truth. There is only the latest version of reality. End of communication. If you enjoyed this investigation, your subscription to the channel and any donation value help us expand the Pneuma project. We would love to read your reflection on the video subject in the comments and your suggestion for the next theme to be covered. Tell us which city you are following us from. I appreciate your company until the end. M.